Hi guys, welcome to my class. Today we're going to discuss about another two ways. I'm going to be a bit fast. So if you want to slow down, you can use, wait, does YouTube have slow down features? Never mind, you can repeat this video. You can skip, you can go back to the previous time to see how I'm calculating ANOVA two ways. I have to speed up because ANOVA two ways is very extensive. Alright, so this is me. You can find me at C9. You can call me at 5263 extension and see me and meet me at during my consultation hour, which I put it on times. Right, first to the website. So today we're going to talk about another two ways, the F distribution. We'll talk about another one ways. If you haven't seen that video, please see that video first because this is an extension to another one ways. Okay, so what is ANOVA one way? Technically, ANOVA one way will have three things, right? The first one is you must have factors. Factor A and factor B. Why name it A and B? It doesn't matter. You can name factor 1 and factor 2, factor C and factor D. It doesn't matter. We start with A and B since this is an extension of ANOVA one way and we use that factor A, just one factor, even though it's one factor, it's factor A for ANOVA one way. We use A and B for ANOVA two ways, right? For each of these factors, it must have level, just like ANOVA one way. So ANOVA one way, when we have discussed it in that video, we have 4 and 5 of them. Here, it's very easy. The least amount of levels that you can have in factors are low and high, just two. Whatever low and whatever high, if their temperature, 10 degrees, 20 degrees. If pressure, 100 kilopascal, 200 kilopascal. Simple. Alright, so when we do this experiment, we combine them. For factor A, blue pen. Factor A, I'm combining whatever low of level A and low for level B and I get these results. And of course, I'm going to put a note there because many of you will ask me. Table of results will be given in final exam, receipt exam, or test. There's no boxes like this, right? You're going to be given table, very professional. So there's A and B, and of course, with two factors, we are going to see interactions. You want to see that, does this A and B interact with one another? Right? Interaction are given by this graph. We call it as response graph, or I'm going to write here the one that you are familiar with, that we've discussed it in class, interaction graph. Right, so when you see these two lines, this line, a red one, and the blue one, right, it doesn't cross one another. It's parallel. Therefore, no interaction. What is interaction, you might ask? Alright, so I'm going to use an equation that you're familiar with. Alright, let's do this. Right. So maybe chemical engineers like to use the word N, right? N. Maybe somebody like to use M, right? So it doesn't matter. So these two are the ideal gas equation, right? So M, we can make it constant. R is of course a constant. And of course, if we make the boundary condition constant as well, we can have the volume of that system to be the same. When they are the same, then we can take it out. So what is left is P and T. So these two interact because of this equal sign. Alright, equal sign. So if P goes up, T will go up. Pressure increase, temperature increase. If pressure drops, then temperature drops as well. This is what we call as interaction. This experiment is done using engineering analysis or scientific analysis, but I am going to teach you how to use ANOVA two ways to see interaction. Right, on to the next slide. Oh, sorry, not yet. Alright, so the calculation is simple for this case. For our case, we use a very professional equations. But I would like to take your attention to these numbers. I'm going to use the blue ink and make a box here. And another one, a box here. Because factors, we have 2, interaction have 1. They must be separated. Look at the factors A and B. Which one of these have a biggest value? 21 has the biggest value. Therefore, this is your main factor. Main factor. Alright, that's number 1. How to know that you have the main factor? Number 1, the magnitude. Number 2, right? Look at these signs. A negative sign will bring down the yield. It's too big. A positive sign will bring up the yield. Okay? Number 3. If your calculation more than 1 or it is less than 1. More than 1 means it happens. It doesn't. Oh, let's not use this millennial word. Not happen in this experiment. Right? Take a look again. So for A and B, A is your main factor and B is your second factor that's affecting the experiment. Whatever they are, A will play the major role that change the output of this experiment, and B will follow suit. AB, the interaction is more than 1. That means it happens in this experiment. Good. As we would like, because the reason why we do ANOVA 2 ways is we want to see the interaction. Now, it is in negative value. That means whenever you combine A and B, it will give you a negative output. So be very careful when you increase the levels of A and B, the result of interaction between A and B will drops. Okay, very simple. So in the next slide, I'll show you the example of interaction. When you have interaction, usually these have a cross. Therefore, interaction exists. Okay, right, interaction exists. You can plot, here I give an example. You can plot X for A and B for Y, right? You can also plot the other way around, B down, A in the response part. This is the response part, yeah? Right, doesn't matter. So you have a cross there, that means there is interaction. Alright, so you can see from the previous slide, it is 1, interaction 1, it doesn't have interaction. That means it happens, but not in this case, and the number is small. If you have like this, let's see, AB is negative 29. That means if you combine A and B, it gives you huge interaction, and it gives a very negative yield. And if you take a look at A and B, right, B is your main factor. I write here the word main factor, right? However, the sign is negative. That means do not increase B higher and higher levels because it will drop. The output will drop. That means B is the one who is actually making the interaction in negative yield. Okay. Again, let's bring Katy Perry in. She's no more a cotton engineer, right? She is now a hybrid car engineer. So a hybrid car engineer means you're going to use electricity in your car. So therefore, you must have a battery. And of course, when you want to drive a car, you won't drive it indoors. You're going to drive it outside. So technically, a blue ink there, this will be your factor A, right? Battery. You have 3 batteries, so therefore the levels for A, small a is 3. Okay, small a, again like ANOVA, one way, level, small a is level. Okay, so these are the 3 batteries. She are going to drive this car, put this battery inside the car and drive it, or test it in the lab with a similar temperature. So I'm going to use another color, red. This is for B, temperature. And of course, similarly, B, small b, is the level, and let's say we have 3. So we combine this, A and B. You want to get results. You want to see interaction. What kind of interaction that we want to see? We want to see, when we combine this, we're going to make a robust battery to the temperature that we are testing them. So let's just skip to the research question. Okay, number 1, what is the effect of metal type and temperature on the battery life? So the response that you are looking for, or she is looking for in this case, is the battery life. How long does the battery last? Number 2, is there a choice? That means she wants to choose which battery is the best to drive in, let's say, all climate. Right, so we want to see the interaction between A and B, or temperature and pressure. Okay, let's see about the levels. So you can see here, the material type A, you have 3 plates. For temperature B, you have negative 9 degrees Celsius, 21 degrees Celsius, and 51 degrees Celsius. This is to mimic. I wrote here mimic. Mimic is to copy. Mimic the driving scenario. Maybe you want to drive this in the cold climate, temperate climate, or the moderate temperature countries, or the hot desert. So you have 3 batteries, 3 type of batteries, 3 type of temperature, and you're going to test them. All right. This is the formula that you're going to use. There's a lot of them. SST, SSA, SSB, SS interaction, and SS error. There are 5 sum of square calculation. There are 4 mean square calculation. And you will have 3 F0. And these F0, you must accept either this one, right? Number 1. Number 2, are there more than 1, or are there less than 1? Right? Number 3, the magnitude. All right. So let's go and do about the calculation. All right. Okay. This is the tabulated data of life in hours when you combine temperature and material type of the batteries. So as you can see, we have 3 types of batteries and 3 types of temperature, 3 different temperatures, right? I use the word the Fahrenheit here because it doesn't matter what kind of unit that we are looking at. What is important in statistical analysis are the data and the results. Okay, so you can see that we have 2 factors, and for each of these 2 factors we have 3 levels. We have 9 groups. 3 times 3 is 9. For each of this group, I'm going to use a green ink here. You can see this one, this box, right? We have this 130, 155, 70, and 180 in hours, right? These are the results of battery life when you combine type 1 and 15 degrees Fahrenheit. Maybe you put this type 1 and put it under the 15 degrees Fahrenheit or negative 9 degrees Celsius, you test it. There are 2 ways to do this. The same battery, recharge until full, deplete it 4 times. Or similar combination batteries, type 1 and the same temperatures, you test it 1 time, 1 go, 1 shot, and for each of these battery, you do the you record the hours. Which one is the best? It doesn't matter. It's up to you. If you think that the first method, which is 1 battery, use it 4 times, or 4 different batteries of similar combination is the best, then it's your prerogative. Okay, so we have 4 replication. N equals to 1, N equals to 4, sorry, N equals to 4 for all of this group. So therefore you have 9 groups, and for all of these groups you have 4 repetition. Therefore you have 36 runs, 36 samples, 36 experiments. Okay, very easy, right? So let's do the calculation. Okay, let's write here the steps. Step 1, total the group. Right, what I mean by that, you can see here there are circles for each of the group. There, circles, right? Circle for the group. How do we get these numbers? Let's say 539. 539, if you plus 130 and 155, 74 and 80, you get 539. Similarly, 150, 188, 159, 126 hours, you get 2623. So you do this 9 times for each of the group, and you get all of these circles. That means total the group. Step number 2, total the A and B. A is your material type, right? So it's the row, and this one is a column. Right? Row and column. Look at these 3 numbers. So these 1738, 1291, and 770 belongs to temperature. I get this 1738 by plussing these numbers 539, 623, and 576. You will get 1738. Okay, similarly for this group and this group. Green pen. So how do you get these values? 998, 1300, and 1501, which is by plussing this. Right? So 539, 229, 230 plus them, you got 996. These 3, you got 1300. And these 3, you got 1501. Okay, step number 2. Step 3, grand total. Alright, grand total is this pink box here. I use the light blue pen, 3799. That means you plus this, you got 3799. And also, of course, you plus these 3, you get 3799. Must tally. That is the first 3 steps on the data tabulation. Alright, the calculation are these extensive. I might ask you to calculate all, but this will be very, very vicious. Maybe I just ask you to calculate one of these 2 few blanks that you have done in tests. Alright, but let's, for the sake of learning, let's just do all the calculation. Alright, so I have a slide here that tells you the sum of square calculation. But there's an empty space here which we'll discuss about the MSE or the mean squared and also the F0 that you need to calculate. Alright, let's back up. I'd like to start my calculation with SST because it's the longest. So there is this symbol, the summation of A, B, and N. That means you must go for all the levels for A, which is the material, all the levels for B, which is the temperature, and all N. That means each and every replications. You need to square them and plus them. So you can see here, all these numbers are squared then plus. Square them first, then plus. Okay? 130, 155, 170. I allow you to do this dot 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 to save your time and write the final number. So how do we get this number? Let's go to this slide. So you can see here, this blue ink will circle this one squared plus this one squared plus this one squared. One by one. Just like Lord of the Ring. Square them. And plus them. The blue color is for total. Right? Minus the grand total. and minus the sample number 36, you get a positive value. Must positive. SS material. Alright, so this is for A. Sorry, need to be very slow. Okay, a red ink. This is for A. That's why you see a small a there. Right? However, take note that in this equation of A or material or factor A, there's a small b there. Since A and B, and have a look, this green pen, this is for B, that's why you see a small b there. However, this one is A, this one is B. If they are in similar number, of course, factor A, I have three factors, three levels. Factor B, I have three levels, so you can put them 3 and green pen 3. Sometimes I'm going to be a bit nasty. Maybe B have 2 levels, A have 4 levels. So these numbers will vary. Okay, so take note. Some of your seniors have made a mistake in putting these values in. Now let's focus on red color and material and also factor A. So you can see here is y, I dot dot. I is x-axis, that means all the rows. That means it's for material. And I have three numbers here. 998 squared plus 1300 squared plus 150 squared. Where do I get this number from? This one, yeah? 998 squared, 130 squared, 150 squared. Okay, minus the grand total squared and the sample number, and you get a positive value for sum of square for A, material. Green color for B. This is ij dot j dot 1738 squared, 129 squared, 1291 squared, and 70 squared. Where I get this number from? This down here. This one squared plus this one squared plus 770 squared. And you get minus the grand total, and you get a positive value as well for SSB. So in another two ways, we have interaction. So I give you a light blue. So this is for AB. That's why you see A, small a, and small b there. And this time you have to divide by the replication. You have 4 because n equals to 4. That's why you divide by 4. And this is yij dot. That means these numbers. And you can use dot dot in between. Alright, where do I get these numbers from? Do you remember the circles? Yes, light blue. 539 squared, 623 squared, 576 squared, plus 229 squared, plus 479 squared, plus 583 squared, plus 230 squared, plus 1398 squared, plus 352 squared. And you will get minus the grand total and the sample number, and not that one. And then minus the SS material and also SS temperature. So for interaction, this have these two extra, and also the this is for grand total. This is material that you have calculated just now. Let's make a line, and this one is over here. Okay, and you have a positive value. And finally, you have this SSE, whereby you have your SST, right, for total, SS material, SS temperature, and SS interaction, and you get, let's use all the colors, positive value. Okay, let's go for the MSE, or mean squared. MS means squared for A. That means you take your SSA and divide by the DOF for A. You can look at the equations there, the formula. That means SSA divided by A minus 1. MSB. Take your sum of square for B, divide by degree of freedom for B. Therefore, it is SSB B minus 1. MSAB. Take your SSAB, divide by degree of freedom for AB, right? That means you have SSAB divided by A minus 1, B minus 1. Now, finally, MSEE, finally for mean square. SS error divided by the degree of freedom, DOF for error, which is SSE divided by AB and minus 1. And finally, finally, you must calculate your FO for A. That means MSA divided by MSE. FOB, MSB, MS for error. FOAB, MSAB divided by MS error. And all this refer to the F alpha V1, V2, or F alpha degree of freedom of level, degree of freedom of error. And either you find H1 or H0 accepted. Alright, so on the next slide, you can write all your calculations on this table. I make it easy for me to mark them. But if you don't want to, I will hunt it down and I hope I can find your answers. Okay, as you can see here, we have 3 F0s, right? 3 F0. 1, 2, 3. Okay, so what are the steps? The next step is not an endgame yet. Some of you like to use the word endgame. Is it because of me? Anyways. First, take a look at these numbers. There are more than one. That means these three, A and B, exist in this experiment. And interaction AB exists. Okay, grammar. In this experiment. Good. Now, previously I said that there's a negative value and there's a positive value. However, if you're genius enough, you might notice that we don't have a negative value in ANOVA two ways. So how are we know that these results are increasing or decreasing? It's very hard to say. So therefore, the best way to do this is to, I'm going to make it like this. I'm going to make or H0 accept or H1 accept. These will tell you that if to seek or to find significance in the experiment, right? Either factor A or factor B either should exist or you can leave it be, right? So that is another way for us to define, is it there or is it not there? Good, all of them happens in the experiment. The next slide will tell you how are we going to accept H1 and H2. Now, take a look. These two, material type and temperature, A and B, have 2 degrees of freedom. Interaction, AB, have 4 degrees of freedom. Therefore, you need to find 2 of them. The first one is, let's say, at alpha 5. Oh, my bad. Sorry. 5%. Another one is this one, 4 degrees of freedom, alpha 5%. Okay, so one is 2 degrees of freedom and one is 4 degrees of freedom. So I hope you know how to find this from the table, right? The statistical table. So you have these two numbers, right? For F alpha V1, V2 of 2 and 27, right? Okay, you have 3.35. That means for factor A and factor B, therefore, it's more than 3.35. H1 accept. It is significant. It happens in the experiment and it's significant. Please do not change. Right? What is significant? I like to use the case study or analogy of boyfriends or girlfriend or partners, right? Your life partners, or maybe just friends. These partners, he or she, right, might exist in your life. He or she might go out with you or hang out with you. But if he or she really significant, can you change this person to another person? If you can, that means that person happens to be there more than one, but it's not H1 accept, it's not significant, it's H0 accept. If that person is significant, you cannot live without this person. Therefore, it is H1 accept or it is significant. Right? This one, 356. Let's go. Here is 273. Is it more than 273? Yes. Then it's H1 accept. Therefore, all exists. A and B, material and temperature, exists in the experiment, and the interaction as well exists in the experiment, and they are all significant, and it happens in the experiment, just as Katy Perry intended. Okay, then we need to build the response graph, right? To build the response graph, take a look back at this, right? At this. So I need my calculator. So this is my calculator, right? My calculator. Okay, my calculator there. Okay, take a look at this picture or this diagram, this table that we have calculated previously. You see all these circles. Why we do these circles? Not just to calculate the total column and total rows. No, we also want to build the interaction graph. All right, if you are making this graph, yeah, let's say here is your temp, let me make it bigger, temperature, which is Fahrenheit, 15, 21, and what is it again, 70, my bad, 70 and 125, 125, right? And here is your material type 1, type 2, type 3. So take a look. The first combination is 539. Therefore, here first combination is, let me reduce. If you hear weird sound in this video, it's because I'm recording this at home. Right? I live in a condo and there are some dogs barking and lorries are honking and somebody is cooking. Oh my dear God. Oh. They still use the mortar and pestle. Can you hear that? And they have been banging for, I think, 1 hour. What are they cooking? Don't answer that question. It's very rhetoric. Never answer that question. No. Okay. Imagine, pretend that you don't hear that noise. The banging of mortar and pestle to cook, making chili sambal. Alright, what was it again? 539. So it's 539. It stops. Oh wow. Divide by 4. Okay, the next number will be 623. Here is 623 divided by 4. So on and so forth. So I am just going to write the results. Let's use green pen. 539. 539 divided by 4. 135. Right, 135. 623 divided by 4. 1, 5, 1, 5, 6. I just round it up. 576. 576, sorry, 6 divided by 4, 144. 144. This is slow process. 229 divided by 4, 56. 50, sorry, what's that? 57. Right? 57. 479 divided by 4, 120. Right. 538 divided by 4, 135. 230 divided by 4, 58. 198 divided by 4, 40, 50. 342 divided by 4, 86. There you go again. 86. Okay, temperature. Oh, where's that? Fahrenheit go? Okay. So, when you plot this, right, you plot this, right, you plot this, you can plot it this way, you see? Now, here the temperature is on the x-axis, and this material type on the y-axis, right, y-axis. Let's take them all. So in this slide, Katy Perry says she will be using type 3. Now, look at this. Do you see any interaction? Yes. As the calculation F0AB says there is interaction and it happens and it's significant, you can see there are two interaction happens. Between this one is material type 3, right? Let's use another color. 3 and 2. This green one is between type 1 and type 2. There are interaction, but not for all of them. Okay. See, she says she is using type 3. Why? Because majority of the points, let's use a red font, majority ink points belongs to metal type 3. The highest one, the highest of the average life response belong to type 3. Therefore, type 3 is the best to be chosen for any kind of temperatures in this case. Okay? Right, even though at 15 degrees Fahrenheit, it is somewhere in the middle. But majority is still metal type 3 wins. Done. Now, if there is a cost analysis, which one is the best? Let's say type 1 is cheapest, type 2 is in the middle, and type 3 is the most expensive. Then how are we going to deal this? Let's say I give you two questions. The first question, cost analysis. All right, cost analysis. Number 2, the question can be customer base. That means I want to give this car have a best battery, cost analysis wise, and customer base. That means most of the people in all of this around the world can buy this new car and these batteries and use them. So to do this, using the light blue ink, take a look at this interaction. Right, this interaction, either metal type 2 and 3 to be combined, or metal type 1 and 2 to be combined. Which one is the best? All right, let's say for cost-based analysis, right, cost-based analysis, you can just go with metal type 1 and 2 because they are the cheapest. Then just go ahead and perform. But if you have to combine cost analysis and the customer base, so most people around the world will live around the temperate climate or moderate temperatures to the highest, hottest countries. Nobody is going to be living near a volcano, inside a volcano, say, or maybe in the desert, in the middle of the desert, so hot, right? Maybe they're going to be living in a city where the temperature is around what? What's the highest temperature around the world? 38, 40, you're going to have a heat stroke, right? So that means our range of temperature will be from this one to this one, right? So the best one to be chosen, cost analysis as well as performance wise for all customer will be material type 3 plus 2. Why? Take a look at this one. This interaction happened between 3 and 2, and most of this graph follows this range of temperature, right? And it has the highest combination at the highest point compared to this one, right? Material type 1. Therefore, the best one for cost analysis and customer base is type 3 and 2. If you just want to go for the cheapest one, just go for 1 and 2, because 1 and 2 have interaction at the highest temperature. That means you can give, for example, I just want to sell this car for people who live in the desert or high temperature climates. Then sell them 1 and 2. It's very cost effective, and also it affects or have a very good effect at the highest temperature because there is interaction between these two. If you just want to choose the highest temperature, the best battery with no interaction, then material type 3. So based on the question and application, you can know that if it's individual choice, then choose the highest response. If there is interaction, then take a look at the interaction. Where does it happen? Right? In this case, we have 2. How does it happen? Does it affect the customer base or cost analysis? So that is your answer. All right. Okay. I should have written it here. Anyways, that is ANOVA 2. Thank you for watching. It's a long video. I'm sorry. I'm looking forward for you to see my other videos. Take care. Goodbye.